Hello, welcome back. We're on to question 6. Grays hockey, legends, and then the channel. My ruler is still out because it seems every question on this paper you need a ruler. So make sure you bring them for your exam. Right, question 6. Water hyacinths are plants that grow in lakes and cover the water surface or the water's surface. When uncontrolled, the plants grow at an exponential rate. The growth in one lake is recorded by measuring the surface area of water covered by the plants. Initially, the plants cover a surface area of 4.5 meters squared. Measurements are taken weekly and a graph is plotted to model the data. Estimate how many days after the first measurement the plants are growing at a rate of 1 meter squared per day. So that's when roughly we've got the graph going up by 1 to 1, because if we look at our axes, 0 to 30, 0 up to 30. So it's got, we just need to find a tangent that's got a gradient of 1. And let where it first hits it there. Okay. Has my graph just done? Looked like it was just about to indicate to me whereabouts that was. It's about there. Happy with that. Oh no, I want to just draw my tangent again. Get into there. Yeah. So that would be my tangent. It's not the best drawing, but I reckon we're in there. So then down we go. And that is 16 days. So you're looking for that gradient to be 1 because the growing rate or the rate of change is gradient. Okay, if it wanted it for 2 meters squared per day, again, you'd be looking at it to have a gradient of 2. Okay, next question. The data can also be modeled by an equation of the form S equals A to the E KD. S is the surface area covered in meters squared. That's the y-axis. D is the days after the first measurement, the x-axis, and A and K are constants. Work out the value of A and of K. So when D is equal to 0, D is equal to 0, then S will equal A to the E K times 0, which is going to be E to the 0, and E to the 0 equals 1, and therefore S will equal A. And at this stage, our S value is the 4.5. So therefore, A equals 4.5. So that's a nice start. Now let's rearrange this equation. So S equals 4.5 E to the KD. S over 4.5 is equal E to the KD. The natural log of S to the 4.5 is equal to KD. And then we're looking for K. So the natural log of S over 4.5, all divided by D, will give us K. Now we just need to find a value and substitute that in. And the value I chose to do is probably not the value I'm going to use right now. It's okay. I mean, that one was all right. This one looks good. We don't have any actual values given to us, do we? So this one looks nice here. So we've got 20, and then that goes across to 19. So 2019 will be the one that I use. 2019, with the x-axis being the days. So D will equal 20, and the y-axis is S. So S will equal 19. So we've got the natural log of 19 over 4.5, all divided by 20, and that's going to give us our value of K. I'll put my A value in there. Now it's a calculation. So the natural log, where is that button? There. ln 19 over 4.5. That's then divided by 20, and that gives me K equals 0.072018079112, which I will call 0.07. Happy. Right. Doesn't ask me to rewrite it, so I'm just getting those values. Part C. State 2 reasons why the model might not be suitable for predicting the surface area of water covered by the plants 1 year after the first measurement. So plant growth might depend on other factors. And then I'm going to put such as the seasons. So it might not grow at a quicker rate or at the same rate in winter. It may be quicker in summer or in spring. And then plants may stop growing unexpectedly. I mean, I'd also say, finally, that they might just cover the whole area that we're looking at. We don't know how big the water is. So they could just exceed the actual population, and then it would reach a plateau and would not continue. Okay, that's question 6 done. One more to go. I'll see you at question 7.